The following diagram shows a graph of function f. There's a minimum, local minimum at a. And it's right here, and it's obviously to the right of the y-axis. Okay, the derivative of f is given by f prime of x is 3x squared minus 8x minus 3. Find the x coordinate of a. Okay, so we want to find this value, and we know that for this x value at a, if you plug it in here, you get 0. So we want to solve this f prime. 0 is equal to 3x squared minus 8x minus 3, and I see that 3 times 3 is 9, and 1 times 1 is 1. And if I make the 3 negative, then I'll get a negative 8 over there. So 3x plus 1 and x minus 3. And you can check your answers to make sure it gives you this original function. And it does. 3x squared, and here's 9 minus 9x and plus x, that's negative 8x, and then minus 3. So if you solve this, x could be either negative 1/3, or x could be positive 3. And we know that x has to be positive, so x is 3. So there. Now, the y-intercept of the graph is 0, 6. So here is 0, 6. Find the expression for f of x. Well, we know f prime of x, so how would we find f of x? So you have to integrate it. So integrate 3x squared minus 8x minus 3 with respect to x, and then you should get 3x cubed over 3 minus 8x squared over 2 minus 3x plus c. Okay, I can just clean that up a bit. X cubed minus 4x squared minus 3x plus c. But we know that if you plug in 0, you should get 6 for y. So here, if you plug in 0, f of 0 is going to be 0 here, 0, 0, and then so 6, c is 6, right? 0 minus 0 minus 0 plus c is 6. So therefore, c is 6. And I know then f of x is x cubed minus 4x squared minus 3x plus 6. Okay? The graph of the function g is obtained by reflecting the graph of f in the y-axis, followed by a translation of mn. So it's a vector notation. You're going to go m units to the right and n units up or down, right? Up. Find the x-coordinate of the local minimum point of the graph of g. So if you were to take this original graph and reflect it about the y-axis, then you would get this. Okay, so let's put it right here, and if you look at it, and this is 3 here, so this must be negative 3, right? And you're moving, like, because I'm only interested in the x-coordinate, I'm just going to look at m. Whatever m is, I move that many units to the left or right, so I just have to add m to negative 3. So the x-coordinate of g is negative 3 plus m.